Have you ever wondered how your online transactions remain secure? It's all thanks to the fascinating world of cryptography. This is the art of writing or solving codes, a sphere that has been instrumental in keeping our digital world safe and secure. Today, cryptography is the backbone of online security. It's what keeps your credit card details safe when you're shopping online, protects your emails from prying eyes, and ensures that your online identity remains just that, yours. But this isn't a modern phenomenon. Cryptography has been in use for thousands of years. Ancient Egyptians used hieroglyphs to hide the meaning of important inscriptions, while Julius Caesar employed a simple yet effective cipher for his military messages. In the digital age, cryptography has become even more essential. As our lives increasingly move online, the need for secure communication has never been greater. That's all for the introduction, but how does this cryptographic magic actually work? Imagine you're writing a secret message, but you don't want anyone else to read it. What do? Well, you'd probably create your own secret language, wouldn't you? A language that only you and the intended recipient understand. This is the core concept behind encryption. It's like creating a secret language for your data to keep it safe from prying eyes. But how does it work? Let's imagine you're at a crowded party and you want to tell a friend a secret. You don't want anyone else to overhear, so you and your friend agree to speak in a code that only you two understand. That's encryption. You've just encrypted your conversation. Now, in the world of cryptography, this secret language or code is called an encryption algorithm. It's a complex set of rules used to convert your original message into something that looks like gibberish to anyone who doesn't know the secret language. But there's another crucial piece to this puzzle. Your friend needs to know how to translate the secret code back into a language they understand. They need a key. In encryption, this key is a piece of information that decodes the gibberish back into the original message. So, you see, encryption is like a secret language. It's a way to keep your data safe and secure. But what happens when the secret message needs to be read? So, we have a secret language, but how does the receiver read the message? Well, that's where decryption comes in. Decryption is like having a master key that can unlock the secret language. Imagine a locked treasure chest filled with secret messages. The lock is the encryption, and the key is the decryption. Without the key, the chest remains locked, and the secrets inside remain hidden. Now there are two types of decryption, symmetric and asymmetric. In symmetric decryption, the same key is used to both lock and unlock the treasure chest. It's like having one key to both your house and your car, but in asymmetric decryption there are two keys. One key locks the chest, and a different key unlocks it. It's like having a separate key for your house and your car. Decryption is like having the key to a secret lock. But how do we ensure that the key doesn't fall into the wrong hands? Imagine you need to send a key to your friend, but you can't do it directly. How can you make sure it reaches them safely? This is the challenge that key exchange in cryptography seeks to solve. Let's take a moment to understand the concept of key exchange. Picture a box, a secure container for your precious information. You lock this box using your own lock and then send it to your friend. Now your friend can't open the box because they don't have your key. But here's the trick. They add their own lock to the box and send it back to you. Now the box has two locks. When you receive the box, you remove your lock and send it back to your friend again. Now the box is still locked, but only with your friend's lock. Your friend can now remove their lock and get to the contents of the box. This is a simplified version of what we call the Diffie-Hellman key exchange in cryptography. In the real world, this box is your sensitive information, and the locks are mathematical functions. The keys are unique numbers that only you and your friend know. This process ensures that even if someone intercepts the box, they can't open it because they don't have the key. That's how cryptography ensures that our online transactions are secure, keeping our information safe from prying eyes.